Hello, everyone. My name is Tamara Branca. I'm an associate professor in the Department of Physics and Astronomy here at UNC. My research expertise is in medical physics. Specifically, I do magnetic resonance imaging and spectroscopy. If you're watching this video, is probably because you are interested in physics and probably you have a very curious mind. Physics basically tell us how things work, but it's also the foundation of other natural sciences like biology, chemistry, geography, engineering. If you major in physics, and you not just learn how things work, the law of physics and the law of nature, but you will also refine your critical thinking and solving skills, which are very valuable assets to have, and not just in physics.
Hi everyone, my name is Madison Barber. I'm from Raleigh, North Carolina, a junior in cohort 6, and a double major in astrophysics and computer science. So a little bit about what I'm involved in at UNC. I work in a physics research lab. I am an undergraduate TA for our Intro Comp Sci class, Comp 110. I'm involved in Visibility in Physics, which is a student-led organization that supports physics majors, minors, enthusiasts, anyone who may feel a little out of place or aren't sure how to navigate the department. And I'm involved with UNC's Glee Choir. So I came to UNC as a physics and math double major, and I knew I wanted to do research, but that's about it. In high school, I took my first physics class ever as a junior and instantly fell in love with it. Everyone was telling me how hard the class was going to be, and I was kind of nervous about it, but the teacher was really great, made the material very accessible, and I just really liked it. I ended up writing my senior project about the feasibility of various asteroid deflection methods, and this really made me realize I want to do astrophysics research specifically.
If you want to study physics, why should you study physics at UNC? Well, we have a very small students faculty ratio. We have one faculty member every 4 undergraduates. And this kind of guarantee a very close attention by our faculty to our students. You also will be able to receive individual attention because the classroom size is small. The average classroom size is about 25 students, but as you move towards your junior and senior year, you may be in classrooms that have as few as 5 students, for example.
One good thing about the physics major at UNC is its size. It's pretty small, so you'll get to know everyone in your classes. We even have a lounge in Phillips Hall, which is the physics building, where we can hang out and do homework together. I've met some of my best friends through physics, and everyone is super helpful with homework if you ever need it.
We also have student-led organizations within our department, like the Society of Physics Students or the Women in Physics. These are student-led organizations that have actual physical space in Phillips Hall that they use all the time, that's dedicated to them. They also organize social events throughout the year, and they also participate to national conferences for undergraduates where they can show their research they have done here at UNC.
I chose physics because I had a great experience with it in high school. I had a fantastic teacher who gave me such a great introduction to the subject that I began pursuing it in my own free time outside of school, and I began to learn how just cool the entire subject really is.
Because we have this small students faculty ratio, all our students participate in research, and not just for 1 semester, which is the minimum required, but for 2 or 3 years. So we had students that come out with the publication that definitely give them a leverage over other students when they apply to graduate program or other schools.
It's super easy to get involved with research at UNC. Just reach out to a professor you're interested in working for and ask if they have any availability. I got involved with an Axion dark matter experiment called Abracadabra during my sophomore year just by reaching out. I'm currently working on my senior honors thesis on a way to improve the experiment.
We have a different research group as all physics department. We have the standard research group in nuclear physics, particle physics, theory, condensed matter. But we also have some unusual research group or a research group that are less common in physics departments, like the biological and medical physics, which I'm part of, the physics education research group, and of course, the astrophysics research group.
For my lab, I work with Dr. Andrew Mann in the Young Worlds lab. I work on modeling the jitter or brightness variability in young stars. So stars naturally vary in brightness due to a number of different factors, but I'm trying to determine if it's possible to model the intrinsic variability of young stars so that exoplanet researchers can take into account this brightness variability of the star when trying to determine if the star is a host to any planets. Previously in the lab, I worked on automated querying processes to look up stellar systems and their characteristics.
Probably the most interesting class that I've taken at UNC or in physics has been Astro 202. It was the Introduction to Astrophysics class, and I took it with Dr. Andrew Mann, who's a great professor. He taught me a lot of he gave me a great basis for astrophysics. He taught me a lot about time dilation, dark matter, exoplanet formation, which I actually just wrote a paper on. And overall, he really just gave me such a great introduction to the subject.
Summers are also a great time to get involved with research and try out different things.
This past summer, I had the opportunity to intern with NASA Goddard Space Flight Center, looking at the light curves of various stars, looking for exoplanets.
The past 2 summers, I've been an intern at CERN. CERN is known for the Large Hadron Collider, which discovered the Higgs boson. My CSS peer mentor told me about the program at CERN and helped me get everything ready to apply. I've been able to work on 2 different kaon experiments and even live in Geneva for the summer of 2019.
Sadly, I have not been able to start research yet. I was planning on starting this past semester, but for obvious reasons that didn't really happen, though I am aiming to start this upcoming semester. I'm kind of looking into mainly dark matter because overall I think that interests me the most, but I'm also looking into nuclear physics because I find that to be also very interesting as well.
We have a variety of different space depending on the type of research we do. For example, the nuclear physicists have research space at Tunnel, which is the Triangle University's nuclear laboratory, which has a research space for all nuclear physicists in the area from UNC, NC State, Duke, UNC Central. If you're interested in astrophysics, we have observational astronomers that look at the sky to look at new planets or stars. And we also have people that work on the hardware that develop new, more powerful telescopes to look at the sky. My expertise is in medical physics. So to just give you an example of the kind of research of our undergraduate do in our lab, my first undergraduate student was Arjun. He worked on functional MRI of brown adipose tissue. Basically, he used MRI to look at the function of this tissue called brown fat. And while I was in my lab, I also developed a LabVIEW control MR-compatible ventilator, which is used to deliver gases and contrast to the lungs of this animal while they're being imaged to look at lung function. And actually, these days, we still use the machine that he put together. After he graduated, he went to a MD PhD program, Harvard Medical School. All our students have very different career path. After they graduate, about a quarter of them go to physics and astronomy graduate program. Another quarter of them typically go to other PhD programs like engineering, BME, mathematics. Some of them go to medical school, some of them go to law school or business school. And then slightly less than half are employed by the private or public sector. In the private sector, they are hired as a research scientist or as a data scientist. In the public sector, typically are government job, teaching.
In the future, I want to be a research professor at a university. On one hand, I want to be conducting my own research. On the other hand, I want to be giving students a good introduction to the subject.
So long term, I want to continue doing research. I loved my internship with NASA, so I hope that one day I can be there in person and not just virtually. And then I also plan on getting my PhD after graduating from UNC, which will help me further become a research scientist.
Something that you will most likely learn very quickly into your career as a physics major is that when you tell people you are a physics major, you will get about the same 5 responses, and you'll learn them pretty quickly. But the main one I often hear is, oh, I had a bad experience with physics in either high school or college, and as a result, it just didn't click with me. And I think that's a shame, because I had a fantastic experience with physics in high school, and as a result, I began pursuing the major. So I think if more people had a better experience with physics in college, more people would pursue the major. So that's why I want to be a research professor.
So what kind of degree options do we offer? Well, we have the standard BS degree in physics and also in astrophysics because of the research group that we have in our department. And we also have a variety of BA degrees. The standard one is in physics, but we also have astronomy. We also have energy and quantitative finance. This is actually very popular among our undergraduates.
And finally, something I would want to tell any prospective physics students is that physics is not an easy major. All right, there's a reason why there aren't many physics majors out there. If the passion isn't there, it's not going to be easy. But if the passion is there, please stick with it. It'll be hard, but I promise it'll be worth it in the end. Make study groups with your peers. You're going to be with them for the next couple of years, and stick with it. Trust me, I promise you'll enjoy it.
Welcome to UNC, and I hope to see you this summer on campus.
I've had a great time at UNC and in CSS, and I'm excited for you as you start on this journey. Go Heels!